Right, I'm going to talk about fission and the nuclear reactor. So, we're going to start off with fission and the process by which unstable nuclei are split and release energy. Now, the main fissile material that we use is uranium-235. It is quite unstable, but it's also very abundant. There's lots of it around. I'm going to draw now a picture you've probably seen before, or something very similar. This is the nucleus of a uranium-235 atom. The coloured in dots are the neutrons, and the non-coloured in ones are the protons. Now, to cause this to split, we fire an extra neutron into the nucleus of the uranium-235 atom. This makes it very unstable, and it splits. It splits into two smaller nuclei. It splits into two or three extra neutrons and energy. Now, the energy that we're talking about here is in the form of the kinetic energy of all these particles. So these two and the two or three neutrons, the kinetic energy of those is the initial form of that energy. It very quickly gets converted into heat, which is what we need and what we use, but initially it is kinetic energy. Now, these particles here, they are known as fission products, or daughter particles. They can be known as either of those. Now, if any of these extra neutrons go on to hit uranium-235 nuclei, they can cause them to split. As they split, these next nuclei also release two or three, which then could go on to hit other uranium-235 nuclei. And this process, this continual process, is known as a chain reaction. This is what we want, but we want it in a controlled fashion. If this chain reaction gets out of control, if too much energy is produced, we get a nuclear disaster like Chernobyl, where too much energy was released, too much heat was generated, and we get fires and a meltdown with radiation or radioactive material being released into the outside world. Okay, we're now going to look at the inside of a nuclear reactor. In particular, we're going to look at the fuel rods, control rods, moderator, and shield. Before we do that though, the heat that gets generated here, which I've just described in the process on fission, is used to heat a gas. This gas then goes on to heat water, which turns it to steam. The steam goes on to turn turbines, to turn generators, and to generate electricity. So from this stage onwards, it's just like a fossil fuel powered power station, where heat is used to heat steam, turn turbines, turn generators, generate electricity. Now, to control the fuel rods, we have, and to control the chain reaction, we have two things. Firstly, we have the control rods. Okay, these are normally made of something like boron, and they absorb the extra neutrons. By absorbing them, these neutrons then can't go on to split nuclei, and it slows or controls the reaction that's happening. The other thing that controls that reaction is the moderator. Can be made out of graphite. Can also be made out of heavy water, but graphite is used. And this slows the neutrons down. This means that when they actually collide with the large nuclei, they're more likely to combine with the nuclei and then split them, rather than just glance off or not collide with the nuclei, just go past them. So that's what the moderator does. It controls it also. We can actually keep the fission happening. The control rods slow it down or bring it to a stop. The last thing then that we're going to look at is this section here. Okay, this is the outside of the reactor vessel itself, and that is known as the shield. This is made of very thick concrete. Very thick concrete, and that stops the radiation from passing through. If it was to pass through, then people outside of the reactor vessel could get affected by it. And that's a nuclear reactor.